Today's lesson is on congruence in overlapping triangles. There's really no new information here. As a matter of fact, in the last lesson, and maybe even the previous one, we did some proof with overlapping triangles. So this is really just more proof practice. So I'll probably do a couple. I'll probably do a couple with you and then save the others for you to practice and then check in class. All right, so we know, after having already done some of these, that overlapping triangles will have a common side or angle. They'll have something in common. And sometimes it may help you to actually pull apart those triangles in doing your proof. For instance, if I look here at this one, if I was trying to prove that triangle YXZ is congruent to WXZ, I might need to pull those two apart. There's X, Y, Z, and there's X, W, Z. So it might help you to draw those separately, or maybe highlight the different triangles or shade each one in. I don't know. Just figure out what you got to do and do it the way that suits you best. Okay, so our first one here, the steps are all filled in, the statements are filled in for us. All we have to do is write down the reasons. So I'll try to, maybe I'll just do it down here. Let me erase this. Hopefully you have room below this. So I'm going to put my reasons. We don't need to rewrite the statements. We'll just rewrite the reasons. So how do I know that YX is congruent to WX? Because that's given. And how do I know that ZX bisects angle XYZ? That's also given. If we did this proof ourselves, we probably would have combined that into one step. Okay, number 3. What does step 3 say? It says angle YXZ, so that's this one right here, is congruent to angle WXZ. That's that one right there. And of course we know that because that angle, that large angle, is being bisected. So we know that by the definition of angle bisector. Okay, step 4. How do we know XZ is congruent to itself? That's the reflexive property. Reflexive property of congruence. And step number 5 says triangle YXZ. So this triangle over here is congruent to WXZ. This triangle over here. And how do we know that? Side angle side, right? I've got the included angle, and so I know that those triangles are congruent by side angle side. And so finally, how do I know that YZ, where's YZ? YZ right here. How do I know that YZ is congruent to WZ? Well, because those are corresponding parts of congruent triangles, of course. So our reason number 6 would be CPCTC. All right, so as I said, we did proofs like this in the last lesson, so that's really nothing new. Let's see what we have next. Another proof here, and as I worked this one on my paper, I ran out of room, so I'm going to try to squeeze it all in here. Let's see. Our given statements are angle K is congruent to angle M, angle N, and angle T are right angles, and NG is congruent to HT. That's a lot of given information. We're going to put it all in one step there. Okay, so let me step back here and take a look at my picture. What am I trying to prove? I'm trying to prove that triangle KNH, this one right here, is congruent to triangle MTG. So this one right here. So wow, I already have, look what I have. I've got two angles. I've got two angles. I need to erase this so I can see what I'm doing. But I already have two angles, two sets of corresponding angles that are congruent to each other. Actually, I better say that because I don't know. I know they told me that K and M are congruent, but I have to come in here and I have to say angle N is congruent to angle T. That's not given. That is the right angles theorem. So now, let's see. I could use angle side theorem if I knew that GM was congruent to HK, but I really have no way of getting there. Ah, but look, if I could show that NH is congruent to TG, then I could say that those two triangles are congruent by angle side. And the reason I know that those are the two things I've got to get to is because they give me this information right here. NG is congruent to HT. So how are we going to get there? Let's see. What I think we need to do is I think we need to say GH is congruent to HG by the symmetric property of congruence. And then what does that let me do? Well, that lets me add GH or HG to both sides. So if I say NG plus GH equals TH plus HG, I can do that by the addition. That is the addition property of equality because all I did is I added HG to both sides. Okay, now how does that help me though? How does that help me? This is a little bit of a tough one. This is one of those proofs where when I started it, I kind of just started writing down everything I knew and then it finally came together. Ah, this is what I need to do. So the next thing that I thought of is let me make some angle addition. Let me use the segment addition property and postulate. Let me do this. Let me say NG plus GH equals NH, segment addition postulate right there, right? NG plus GH equals NH. And I can do it for the other side too. I can say TH plus HG equals TG, segment addition postulate. Now, let's see if that gets us anywhere. What can I do now? How about if I use substitution, right? Look, if I have, look at this closely, I have NG plus GH and NG plus GH. Okay, they equal two different things. So how about if I just use substitution in both of these cases, and I can come right on in here and say I can substitute NH into here, and I can substitute TG into here, and that's really what I need because you see that's just what I was trying to get to right here. So I can just now say that NH equals TG, and how did I get there? By using the substitution property of equality. All right, so now I have it, right? I have two angles and the sides I wanted. Oh, but wait a minute. Here's what I needed. I'm not quite there, right? So what have I got to do? What do I have to do? Oh, I have to change number 6 to a congruence statement. So I have to say NH, because remember, all my triangle congruence postulates or theorems depend on congruence, not equality. So NH is congruent to side TG. And remember, I can always do that by the definition of congruent segments. Definition of congruent segments. And then finally, I'm ready to say, and I did run over, sorry about that. I'm ready to say that triangle KNH is congruent to triangle MTG by angle, angle, side. The angle, angle, side theorem. Okay, that's a little bit of a tricky one. Definitely is. Okay, the next proof is also, I would consider it to be fairly difficult. So I'm not going to try to go through it on this video. We will look at that in class at some point before our test. So actually, after I finish this, I'll put the solution to it up here. Well, yeah, somehow we'll get it to you so that if you want to try to work this as you study for your test, you'll have the solution. Just don't let me forget. All right, let's see what the next proof looks like. Yeah, it's a bit shorter. It's a bit shorter, so we'll go ahead and do this one. Statements. Reasons. Write down our given. RT is congruent to AS, and RS is congruent to AT. So let's see what that's telling me. RT is congruent to AS, and RS is congruent to AT. So there, that's what I have of those two triangles. Hopefully this one is pretty clear. I have no way. What I would need here is to be able to show that angle, if I were going to use an angle, I would need to be able to show that angle RST is congruent to angle TAS. Actually, that's what they're trying to get me to prove. So I got to show that these two triangles are congruent. And the best way, probably the only way for me to do that is by side, side, side. So what I got to do come in here now is come in and say, if I'm looking at RST, that ST is congruent to ATS. So once again, I got to use the symmetric property. Symmetric property of congruence. And now I have it right. I have my triangles. Triangle RST is congruent to triangle ATS by side, 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 congruence postulate. And so now those two angles that we're looking at, angle TSA is congruent. Oh, that's actually not the angles I marked. This angle, TSA, is congruent to STR. So, oh yeah, those are the little bitty angles. Sometimes these overlapping triangles are really hard to see, but those definitely are corresponding parts of those two triangles. So I'm just going to use CP, C, T, C. There for a minute. Originally, guys, I thought I was looking for these angles, but that's not the angles I was looking for at all. I was looking for this one, which is part of this triangle, as you see. This angle, definitely part of that triangle. And this angle here, right, definitely part of this triangle. So not the angles I originally thought I was looking for, but corresponding angles nevertheless. Oh, I forgot to write it in there, STR. So there you go, a couple of proofs to help you work with congruence and overlapping triangles. Our last lesson of the unit will be on isosceles, equilateral, and right triangles and proving them congruent. And we'll see you then.